a quick intro to equations. Here it goes. Now, in the past, I know that you've been working with equations ever since elementary, solving equations, so on and so forth. Here goes a quick intro. Now, equations started a long time ago, and let me give you one approach. Here it goes. Who's seen these? Yeah, right? Those are scales. Back in the day, they used to use those to sell and purchase products, okay? And how this worked, the merchants had these bronze cylinders that were labeled 1 pound, 2 pounds, 5 pounds, and so on and so forth. Everybody see that? Yeah. So in order for them to sell or to buy products, they would add these to one of the sides of the scale in order to start weighing whatever it is that they were going to sell or buy. So on a regular day, a particular day that, let's say we go to the supermarket on the street back then when we used to wear togas and stuff, right? So here we go. We're all in the marketplace, and I went to an establishment and I said, yes, sir, can I get 8 pounds of frijoles? All right. So then the person would add 8 pounds to one side and it would drop. Is that correct? Yeah. So therefore, how it worked, the owner would, or the person attending to the establishment, will put a sack on the other side, start pouring frijoles in there, and bam, there it is. It will start filling up until when? Until it balanced out that it was 8 pounds. That's how that worked. And that's where the idea of whatever you do to one side, you do to the other side comes from, because it needs to stay balanced. Does everybody see that? Same thing if they were to use the other side, starting from the other side. That's why, check this out. If I was to start from this side, 11 pounds on this side, what do I need to do to keep it balanced? Add weight over here till it hits what? 11. That's how we balance it, and that's where equations come from. Are we there? Now check this out. Now, with that idea, if this was to be an actual scale, it would have like a base like this, right? And it would be on a table, such as this, right? Everybody see that? And there's my table, there's my scale, and they would be weighing stuff. Are we there? Yeah. Now check this out. The original scale, or when it's balanced, is from here to here, and it's straight. Is that correct? Yeah. And do you see the table here? Yeah. Yes? Do you see the symbol for me?
Equal.
Did everybody see that? Yeah. You guys see it? Yes or no? Yeah. Okay. For those of you that don't see it, here it goes. There's this one and this one, and they form an equal sign. Everybody see that? With that same idea, check this out. After we go over this, check this out. What do we have here? 0. What do we have here? 11. What was the original position of this? There. That's why we do this.
How do you know this? That's why I always wondered.
Yeah, and who remembers your teacher? And the alligator ate the no. and the Pac-Man and right. So check this out. Same thing with this. If I was to go the other way like this, what's on that side? It's 8. What's on this side? 0, and my arrow should point that way. So therefore, we got equations, we got inequalities. Today we're going to continue with equations. Today will be our first lesson on equations. We're going to continue with those. So, copy the homework down, though. On a separate sheet of paper, write, use window notes to solve the following equations. Number 1, -8 plus y equals 31. Number 2, 50 equals -6 plus x. Number 3, w minus 2.5 equals -38.09. Number 4, -28 equals 7k. Number 5, 6 equals 3/5 times m. And number 6, a divided by negative 6 equals negative 24. Copy that, please. I'll give you guys 30 seconds. What? Okay, 35 seconds. Go. So, it says here you're going to do window notes for this homework. Okay? Yeah, I know, right? So, let's continue. Our objective for today, I can solve and graph one variable equation. Let's read it together. 1, 2, 3. I can solve and graph one variable equation. So our new concept for today is one variable equations, right? Therefore, write that in your FAIR model, please. One variable equations definition. The mathematical statements where two expressions are equal to each other and contain one unknown variable. Examples. X plus 2 equals 25, 12 equals y minus 8, 2a equals 14, and negative 3 equals m over 4. Also, 3x plus 2 equals 25, 12 equals 4y minus 8, 2a plus 8 equals 4, negative 3 equals m over 4 minus 6. And none examples. We got x plus 5 minus 25, 12 greater than x minus 8, x squared plus 5 equals 30, and 4x plus 6 equals negative 2y. Okay? Copy those. So, according to the definition, it says statements where two expressions are equal to each other and contain one unknown variable. Okay? So check this out. If I was to cover this part, isn't this an expression?
Yes.
Yeah, it's an algebraic expression. Same thing if I was to cover the other side. Isn't this an expression? Yes, it's a numerical expression. Are we there? Because it's 25 times 1 or 25 divided by 1 because we make it into a fraction, right? Therefore, do we have an expression equal to another expression? Yeah, that's what it says. A statement where two expressions are equal to each other and contain one unknown variable. Does it contain one unknown variable? Yes. Look at this one. Yes, 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 and yes. Therefore, look at these. Why are these not one variable equations or not qualifying for what we're looking at as one variable equations? Talk it over with your neighbors, please. So, this one. Okay.
Yes.
Why?
Okay. Well, the first two don't have any equal sign.
Okay, so if this one doesn't have an equal sign, what is this called?
It's called an equation. Yes.
If it doesn't have an equal sign, it's
Expression.
an expression. That is correct. And this one doesn't have an equal sign, but it has a name also. What is that called?
I don't know.
Inequality. Inequality. Okay? So, let me get someone else for this one. How about Marissa? Why do you think this one is not a one variable equation?
Because it's squared.
Okay. Technically, this is a one variable equation. Except for what? What do you notice different from these?
It's squared.
It's squared. This is what we call quadratic equations. These equations that we're going to be looking at first, these we're only going to have one solution. Guess how many solutions will be in this one? 2, because of the squared. So right now we're not going to use these, we're going to use linears, which is these. And the last one, Noemi. There's 2 variables, and we're looking at one variable equation. So what is the most important thing to remember about one variable equations? That they have equal signs, one unknown variable, and no exponents greater than 1 on the variable. Copy that, please. 20 seconds. Okay, here we go. Let's move on. Steps. Write these down. It's only 4 steps. Only 4 steps. So, step number 1. Simplify each side of the equation and in parentheses write start with grouping symbols and combining like terms. Step 2, isolate the variable by using inverse operations. Step 3, plot your solution on the real number line. And step 4, check your solutions by substituting the value of the variable into the original equation. Now, for those of us that need clarification, isolate, I'm pretty sure some of you, or maybe not you guys, but you have friends that have gotten referrals. On the referral it says isolation or something like that. Good. Be nice. Okay. So in there's one checkbox that says student was isolated. What does that mean when the teacher separates you from the entire group or changes you from seat? That's what isolation means. So step 2, it says isolate the variable, which means we're going to leave the variable by itself. Okay? So copy that, and once you're done copying that, I want you to circle the first keyword on each step. So step 1, you circle the word simplify. Step 2, the word isolate. Step 3, the word plot. And step 4, the word check. So like that, we use those keywords to remember the steps. Okay? Copy that, please. Yeah. Yep. We'll cover that this year, so hopefully we'll clarify. Copy that, please. Okay, so the steps. Here we go. Step 1, simplify. Step 2, isolate. Step 3, plot. Step 4, check. Simplify, isolate, plot, 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 check. So now you know them, right? Tell your neighbor the steps, please. Okay. So another term that I'm going to be using throughout this lesson, pay attention please, is inverse operations. First of all, the operations, let's see. We have addition, subtraction, multiplication, and division. The inverse of those are, inverse of an addition is subtraction, inverse of subtraction is addition, inverse of multiplication is division, and inverse of division is multiplication. Now later on when we get to multi-step equations, we're also going to have something like this. Something that has a radical in there. What cancels the square root? A squared. Okay? And we'll get to that when we get to those. Okay? So for right now, copy this one down, please. Example 1. Solve the equation y minus 8 equals 24. And today we're introducing also 4 properties. 4 more properties. Okay? Two of those properties is the addition property and subtraction property of equality. Addition property of equality and subtraction property of equality. The other 2 are multiplication property of equality and division property of equality, and we'll get to those in a little bit. Okay? So here we go. Let's go over this together, step by step. Here it goes. So, I know this is one of probably the easiest lessons that you're going to encounter, but I just want to make sure that we clarify things from the beginning before we start getting into the most complicated or funner stuff, yes? So here we go, everybody look up. So this is what I tell my students to do. Whenever you get to an equation, automatically draw your scale down the middle, the equal sign, so that we know that we need to keep this side and this side balanced. And that takes us to the beginning of the lesson, right? To remember how this is an actual scale. Therefore, isolate means that we need to leave the variable by itself. So on which side do you see the variable? On this side. Here it is. We need to leave this one by itself. Therefore, by leaving the variable by itself, we need to get rid of anything that's around the variable. So the first thing that's around the variable is minus 8. So what is the inverse of minus 8, everyone? And that's why we do plus 8. And whatever we do to one side, we do to the other because we need to keep it balanced. Is that correct? So therefore, what is this? This is a 0 pair. Do you guys see the 0 pair here? This cancels. We're left with y equals 32.
My teacher told me I never got that because when like on the left side she just always said they cancel out and I didn't get why they cancel out, so I always get these wrong.
0 pairs, yes. Okay, so here we go. So let's see. Step 1 said simplify. Can we simplify anything on each side? No, it was already simplified. Step 2, isolate. Did we isolate the variable? Yes. Step 3. What does step 3 say? Plot. Okay, so therefore we're going to plot our answer on the number line. Underneath that, I want you to draw the real number line. We get 0. You do 1, dot, 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 32, and you plot your point. Now, once again, everything that we do in class has a purpose. And some of you are saying, Mr. Q, why are we graphing just that? Because I'm getting us ready for the next step and the next concept that's coming. And if your brain is ready up to right there, we'll be ready for the next thing that's coming. Boom. So let's see. Simplify, done. Isolate, done. Plot, done. What's left? Check. Let's check this. So on the side, we're going to write check. Write the equation y minus 8 equals 24. And instead of y, we're going to substitute what value? 32, because we're going to check to see if it's true. Okay? So we bring everything down. Minus 8 equals 24. 32 minus 8 is 24. Is 24 equal to 24? That is correct. Now, that's all in all pretty good, right? But since you're doing window notes over the weekend, you need to know the properties being used. So check this out. Everybody look up. What did we do to each side here? Added. Therefore, this is the addition property of equality. Because we added to both sides. What happens if we subtract to both sides? Subtraction, properties of equality, and so on and so forth. Okay? And since we have 4 operations, division and multiplication, yes?
Is it called
Of equality.
Equality because you do it to each side?
Because it's an equation and it's keeping it equal, yes. No, let me just get through this. The problem will be you just work it out on one side and write the properties on the next and do the summary. Okay, let's do the next one. Copy this one down, please. 4.2 equals t plus 1.8. Bye, have a good game. Be nice. Okay, here he goes. So, first things first, draw your scale down the equal sign. And can we simplify this side? No, that's already simplified. This side? No. Therefore, my variables here, we need to isolate it, leave it alone. Therefore, what's next to that? Plus 1.8. So what is the inverse of plus 1.8? Minus 1.8 minus 1.8. Do you see the 0 pair right here? So it cancels. So we're left with t equals 42 minus 18, that's 24. You bring down the decimal. There it is. 2.4 equals t. So simplify, done. Isolate, done. Plot. Let's plot our answer. Draw your number line. 0. Let's see, we got 1, 2, 3, 1, 2, 3. 2.4 is about right there. 2.4. Now, check this out. Let's check. So, we write our 4.2 equals t plus 1.8. But instead of t, what are we going to write? 2.4, and you bring everything else down. 4.2 equals 2.4 plus 1.8. If you don't know how to add horizontally, then stack them. 2.4, do that vertically. 1.8, 12, we got 1, 4, yep. 4.2 equals 4.2. All right, I did all the work here. Let me go to the side of the process. Step 1, what is this property called that I did? It's not additive, it's what? subtraction property of equality. And what does that mean? Subtract 1.8 from, bless you, each side of the equation. I'm going to abbreviate equation with EQ. What do we do from there? From there, I write plot solution on number line. What do we do right after? Check for, yes. That's what it is. When we did inverse operations, we already isolate. Yeah. Check for correct answer. And at the end, 10Q. Okay? Therefore, do you know what to write here? I was given, right? I was given 4.2 equals t plus 1.8 to solve for t. First, I use subtraction property of equality, yada, yada, yada. Everybody see how that works? Yes, Mr. Q. Good. All right, let's go to the next one. I'm going to skip these, and I want to get to this one. Copy this one, please. Example 5, negative 8 equals j over 3. All right. Our scale down. So let's see. Here's j. We need to leave j by itself. What's happening to j? It's being divided by 3. So what is the inverse of division? Multiplication, and we need to get rid of that 3, so we multiply times 3. Multiply times 3. Now check this out. Your teacher's probably told you that this cancels, and that is incorrect. 3 over 3 is 1. Because if it was 0, then we would end up with 0 on this side. Is that correct? So therefore, 3 over 3 is 1. What is 1 times j? 1j. That's why we leave it as j. What is 3 times negative 8? Thank you. Negative 24. And you know how to plot. You know how to check. Thank you. Are we there? Okay. Now check this out. As you're wrapping up, look at this one. This one is multiplying. Therefore, you need to divide by negative 6, divide by negative 6. What property is that? Division property of equality. Now the last one. Look at this one. Look up, please, really quick. It has 5, 6w equals negative 20. On this one, this is a refresher from last year, you should multiply times the reciprocal. Why? Because what is 6 times 5?
30.
What is 5 times 6? And what is 30 over 30? 1. Therefore, we multiply this side times 6 over 5, and that's how we find our solution of negative 120 over 5, which is negative 24. Good one, guys. Homework for the weekend are the 6 problems. Window notes. Have a good one. See you guys till Monday. Bye.